What's up guys, it's Marius from Audio Judgment, and today I'm going to show you how to measure the Thiele Small Parameters using your sound card. Again. I'm doing this because after I posted a tutorial, RumiQ Wizard changed the interface and it was awkward to follow the steps in that video. Then I posted an update showing how to use the new interface, but even after that, there are still some errors in my videos and I'm fixing the problem. I'm deleting the old clips and making this new one. Hopefully it will end up clear and correct. Now let's talk some facts. You want to measure the impedance and Thiele Small Parameters of a speaker. What are your options? Well, realistically you got the DATS V3. How much is that? At the time of filming it's $130. If you build speakers and measure them all the time, the price is quite decent. If you compare it to the next best thing, which is almost $700, you realize that it's actually great value. However, if you're a hobbyist and just like to play around, it's hard to justify spending $130 for doing a couple of measurements. Before we get into the DIY part, let me show you the process of measuring the Thiele Small Parameters using DATS. There are different techniques for measuring TS parameters, but I'm going to show you the one which is the most straightforward. I'm planning to make another video in which I compare different ways to measure TS parameters. Anyway, you have the speaker which you want to measure, and you place it on a sturdy desk or table. You don't want to place the speaker directly on the table. I like to use two erasers. The reasoning is to stop the speaker from rattling against the table, and also if the speaker has a vented pole piece, it will not obstruct the airflow. This speaker doesn't have a vented pole piece, even though you can observe a hole there. Next, you connect the speaker to the DATS and click Measure Free Air Parameters. You will hear a sweep, and now you got all the electrical parameters of the speaker. You're not done yet, you still need the mechanical parameters, and to do that you need to do another measurement while adding weight to the cone. You need some material that will stick to the cone, but not so sticky that you can't get it off afterwards. Some Play-Doh works well, blue tack also works, which I'm using right here. Roll it up into a circle and place it evenly on the cone. Before you do that, make sure you weigh it. You need to weigh it with a precise scale, at least with 1 decimal point. Note down that weight as we will need it later on. Then stick it to the cone as evenly as you can. How much added mass should I use is a guaranteed popular question. Enough to lower the FS, the resonant frequency, by 25% or more. Adding too much mass is also a problem. Don't exceed the moving mass of that speaker. How can you tell? You don't. You just eyeball it at first, do some measurements and see if you got it right. That will give you warnings if you don't have enough weight. I'm not sure RumiQ Wizard gives notification about this. Most likely not. RumiQ Wizard is the software we'll use to do the DIY measurement if you haven't figured that out already. And we will call it RU for short. Before we continue, we need to know the effective diameter of the speaker. An easy way to measure it is to use a caliper, align it against two opposing screw holes, and measure from the inside of the surround on one side to the exterior side of the surround on the other side. With these two numbers, we go to DATS software, input the diameter of the speaker and the added mass weight, and then we click Measure VAS. After the second measurement, we have all the TS parameters. This is the process if you have a device designed for measuring TS parameters like DATS. We are going to save these parameters as we will compare them to the DIY measurement. The measurement process is the same, only that the software is different and you have to build your own contraption. Also, you need an adequate sound card. I failed to mention this in my previous videos. I even showed the schematic with the laptop combo jack, even though I used an external sound card for the actual measurement. The combo jack won't work for sure because it has a mono microphone input. Your sound card needs to have a stereo microphone section. Don't think that if you get an external sound card, automatically you have a stereo mic. Most cheap ones have a mono mic input. Furthermore, most sound cards don't specify if the microphone is mono or stereo. And believe me, it's a challenge to find a sound card with a stereo mic input. Let me give you some examples of budget-friendly sound cards. If we take a look at these hexagon sound cards, we can tell that one has a mono microphone and the other has a stereo one, because it's mentioned on the box. It's good that we have a sound card that is not suitable for this measurement, because I can show you how to tell if the microphone input is stereo or not. Here is a deceiving scenario. This U-green sound card says that the appropriate connector for the microphone is a TRS jack, which suggests it's stereo, right? Wrong. I don't know why, but the mic section is mono. Here's how to tell. You get a stereo jack plug. Where do you get one? Well, you'll have one anyway if you want to build the measurement jig. The plug has two tabs, one shorter and one longer. Those are the positive terminals for the left and right channels. You stick this plug into your microphone socket of your sound card, get a multimeter and set it on ohms, and measure between those two tabs. If you get a very low value, like in this case with the U-green sound card, then the two channels are shorted and you basically only have one channel. Same thing happens with the cheaper hexagon sound card. In the case of this Creative Sound Blaster card, nothing happens. This means that one of the channels is not connected to anything and it's still a mono mic input. Now let's see what happens when you connect to a sound card which does have a stereo mic. I have this improved version of the hexagon sound card and this Asus Xonar U3. The multimeter should read a very high value, 14 kilo ohms for the hexagon and 19.4 kilo ohms for the Asus. Another sound card that has a high chance of having a stereo microphone is the onboard sound card of desktop computers. I tried the front panel connections of two different desktop computers and both worked. Okay, we did a lot of talking and we didn't build any measurement jig. Let's get directly to it. Here is the schematic. You need two jack plugs, one mono and one stereo. I got a lot of comments asking why do I use a mono jack, because the second channel will be shorted to the ground. Yes, that's true and perfectly fine. We only need one output channel since we are measuring a single speaker. And a mono jack plug has one less connection terminal, which is less confusing for beginners. I'm not going to bore you with the building process, I just want to show you something. Here is how a stereo jack plug looks like. The short tab is the left channel positive terminal and the long tab is the right channel positive. And the big tab below is the ground. What I want you to make sure is to connect this side of the resistor to the short tab. It still works if you do it the other way around, but you have to use different settings in RU afterwards. So make sure to do this so you can copy my instructions later on. Make sure to use heat shrink tubing to isolate the channels. Otherwise, there is a high chance of shorting things out and you're wondering why it doesn't work. Regarding the resistor, get a 100 ohm resistor. 1 watt is plenty fine. One thing to make sure is that you measure the resistor before you build the jig. Don't forget this. The resistor is rated at 100 ohms, but it has a value tolerance. So get your multimeter out, measure the resistance of the test leads, then measure the resistor and subtract the resistance of the test leads. Note down that value somewhere because we will need it later. In this simple scenario, some would say that connecting the headphone output directly to the microphone input can damage the microphone section of your sound card. Unless you have some sound card with some beefed up integrated headphone amplifier, I think there is no chance. Furthermore, there is the discussion that the voltage might be too low to drive the speaker. Now, normally measuring Thiele parameters is done at a low level anyway. There are a lot of numbers thrown out there, but it seems to me that between 0.1 and 0.2 volts measured at the speaker terminals is the value to aim for. Having it closer to the upper limit is beneficial because if the signal has a higher voltage, the measurement is less prone to outside noise. In case you didn't know, when you do the measurement, the environment needs to be silent. Outside noise corrupts the measurement as the speaker acts like a microphone and turns acoustical noise into electrical noise. If the speaker is driven with higher voltage, this problem is mitigated. when you use a headphone output, you don't have a say in what voltage you use. You just crank it up as much as possible while making sure it's not clipping. And still, you will be below 100 millivolts. In my tests, I was measuring 20 to 30 millivolts. If you want to increase the voltage, you need to use an amplifier. However, now your amp can pump out enough voltage to drive the speaker at a respectable level, but too much that you can burn your microphone input. In this case, you need to implement a voltage divider to keep your sound card safe. Another thing that's different, since the amp is more familiar with low impedances, a smaller resistor is more fitting. A 10 ohm will do great, but don't get too hung up on this. A 20 or 30 ohm resistor will work as well. Just remember to measure it precisely. I'm going to show you how to do the measurement with both jigs, with and without an amplifier. First off, let's start with the basic jig without the amplifier. Here is how mine looks like, this tiny little contraption. We have the jack plugs at one end, the resistor is somewhere over here, and the alligator clips at the other end. Make sure you get the RumiQ Wizard installed. I'm sure you can find your way in downloading the app using a Google search. And finally, let's get to the measurement process. Now we have our measurement setup ready. We have the speaker on our two erasers. We have the added mass, which we measured at 10.85 grams, the measurement jig, and this is a calibration resistor. It doesn't matter which value it is. The important thing is that we need to measure it precisely. And I got this multimeter over here, which I set to ohms. Let me put it in frame. And we short the probes, 0.1. Get the resistor, 27 ohms. This means 26.9 ohms for this resistor. And we also need to measure the DC resistance of the speaker, which is 3.2 minus 0.1, it's 3.1 ohms. And you need to write these numbers down. We also measured the diameter of the speaker, but RumiQ Wizard actually uses the area of the speaker for some reason, so we need to do a small calculation. We know that the diameter is 127 millimeters. We divide this by 10, so we get the centimeters. And we divide this by 2. This is the radius, and the area of the circle is the radius squared times pi. So we multiply this by itself and then by pi, which is 3.1415. And this is the area of the speaker. So write this number also, 126.67 squared centimeters. And before we start RumiQ Wizard, make sure you install the latest drivers of your sound card. The sound card is found over here. We are gonna use the front panel. This is the microphone, and this one is the microphone. This one is the headphone. And we're going to connect the stereo jack to the microphone and the mono jack to this one to the microphone, this one to the headphone. Gonna get this out of the way, we don't need it anymore. So stereo jack to microphone and mono jack to headphone. Now I also have these working USB sound cards, which I'm not going to show the process, even though it is slightly different when you do the actual settings. So first of all, make sure that you have the latest drivers. This sound card does not have drivers. It says it works with the generic Windows drivers, which indeed it does, but it's a pain to set up. And after you set it up, you get a wrinkly impedance curve, and I don't recommend this sound card. So even though you have a stereo mic input and will work, it doesn't work as intended. So the sound card does matter. This is the Asus Xonar U3, which is better in my opinion than the Realtek onboard sound card, but this one is discontinued, so you can't buy it anymore. It's easier to set up and it works just fine. But I'm guessing many people will have an onboard sound card on their desktop computer, or maybe you have an old laptop which doesn't have a combo jack. That will probably work as well. So first of all, make sure you install the drivers, then go to settings in your Windows. So this is the output, the Realtek high definition audio, and go there and disable any weird audio effects. So make sure this is off and you can leave everything be. Do the same for the microphone. If you have some sort of effects your sound card may or may not have, make sure you disable them. Then we can start Room EQ Wizard, and go to Preferences. And we select our speakers. This is the output, Realtek high definition audio. And the input is the microphone on the Realtek high definition audio. Now, if you made the jig, how I made it, you can select these as I do, L, 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 and R here. If you want a trick to remember them, L forms an L shape, and what's left is an R. Now make sure you tick these boxes, which allows you to control the volume of the headphone output and the microphone input directly from RU. So this overrides whatever settings you have on Windows. And we basically have to do some starting point and then do adjustments over here. So these are your adjustments, which will be different depending on what sound card you have. Ideally, you would want the headphone output to be at the maximum, but sometimes it might distort. But remember that the headphone output is lower than ideal. So even at maximum, you are not at the ideal voltage level. So keeping this at as high as possible is desirable. So I'm going for the max, and input volume, I don't know, something like 60%, I don't know, something like that. We're gonna change these for sure. Then we can go to measure, select impedance, select your range. I usually go from 20 Hz to 20 kilohertz. And here you have to input your sense resistor. I have 98.4 already input. You should know this value when you made the jig. Make sure you measure the sense resistor before you made the jig, because you have to input the value over here. Then make sure that the probes are not touching each other. I'm gonna leave them dangling and make sure they are not touching, and select open circuit calibration. As you can see, we have clipping. This means that we need to do adjustments, either lower the headphone volume or lower the microphone input. In this case, I presume that this is too much, so I'm going to lower it. I'm going to do a significant amount and do adjustments later on. Probably I'll get clipping again. So we try once more. Hopefully, nope, we still get clipping. Let's go to 70%. Try again. And again, clipping. This is unfortunate. Go to 60%. Let's see if that works. Again, clipping. Let me reduce the microphone. Oh. So this worked. Next thing we will do, we will short the probes and click short circuit. And now we have the reference calibration. The value of the resistor is 26.9. And we have to hook that resistor. Click OK. Now everything looks good. If you have noise here, you have to make changes. So in this case, we don't have noise. So these settings are good. But let me show if I go to 70%. So even the open calibration went well, the short calibration went well. And when you reach reference calibration, if you have noise, especially in your upper spectrum, you need to make adjustments. You don't like this. So if you see this, if it is a little bit like this, you can ignore it. If it's noise like this, you have to make adjustments. So either lower the microphone input. Sometimes when you increase it, you reduce noise. On the headphone output, only if you reduce it. So this is too much. We know that 60% is good because there is no noise over there. So if we do this calibration again, we can see that the noise is gone. So I'm telling you this because every sound card is different. So these are your settings which you play with: the headphone output, then the microphone input. Ideally, the headphone output should be as high as possible, like I said, because even at maximum, you usually don't have the necessary voltage that you need. You need like between 100 millivolts and 200 millivolts, and I'm guessing here is like 20 maximum. So now we're done with the calibration. And we can hook our speaker up. Let me check the polarity. So we have our speaker hooked up. And when I will hit start, you have to shut up because it needs to be quiet when you're doing impedance measurement, especially when you're using the headphone output, which has a low voltage. Okay, looking good. Now we have to do another measurement with the added mass. So try to spread it as uniform as you can. Don't go crazy. And tap it all over the place so you know it sticked. That looks good. Going to shut up and do the measurement again. Okay, great. Now go to Tools, Thiele Small Parameters, And we have the added mass method. The freer measurement is this one, first measurement. And the added mass measurement is the second one. And added mass is 10.85 grams. Voice coil DC resistance 3.1 ohms. Effective area of the cone 126.67 square centimeters. And that's pretty much it. Calculate parameters. And these are our Thiele Small Parameters of this speaker using the jig without an amplifier. Regarding the jig with the amplifier, I got a little lazy and used Werq connectors. You can check out the sense resistor, which measured at 9.9 ohms. And also the little resistors are for the voltage divider. The cable between the headphone output and the amplifier input you can buy already made, or you can build your own using a mono jack plug and an RCA plug. So this is the setup within the amplifier. We have the speaker in the same position, our desktop computer with the onboard sound card, and we have our jig with the sense resistor, voltage divider, those little resistors over there. I don't know if you can see them. And the headphone output is wired to the input on the amplifier, and from the speaker out of the amplifier it goes into this jig, and this one uses 9.9 sense resistor, so you have a lower value for the sense resistor. Between 10 and 30 ohms should be fine. And basically now we can fiddle with the volume knob, and we can increase the voltage of the measurement. So before we do any calibrations, I want to hook up the jig and set the levels of the amplifier. Okay, great. Now if we start the Room EQ wizard, let's do the settings all over again. So speakers, where is it, microphone, and when it comes to the amplifier, I just go to 50 and 50% because I'm guessing this is a winning combination, and then I'm going to fiddle with the amplifier knob till I get the right voltage, and then I'm not going to touch the output volume and only work with the input volume until I don't get any clipping or noise, whatever. So this is 50% and 50%. We're done over here, and now we're going to play only with the amplifier volume knob. So the sense resistor is 9.9. I'm not going to worry about the calibration just yet. I just want to set up the amplifier volume levels. Okay, let's go to start. That's too much. I'm going to lower the amplifier just a bit. Try again. That seems about right. Maybe a bit lower. I seen 260. Went just a bit lower. You don't have to be precisely like the dads. So if I go for max, 250. 250 max. I like this level, so we're gonna keep it like this. I'm going to get the multimeter out of the way. And now let's start the calibration process. So we clear the calibration, set the value of the sense resistor, which we already did. Take these probes off. Make sure they are not touching each other. I'm going to leave them on the ground. Open circuit calibration. It says to increase the input level. So that is what I'm going to do. Let's go to 70%. Maybe 75%. Try again. Looking good. So short out the leads, click the short circuit calibration. Looking good. Then the reference resistor, hook it up. The resistor is connected. So we can see we have a little bit of noise. This is sometimes unavoidable, but this is quite acceptable. So I'm guessing I'm not going to do any fiddling at all. I still have this noise. I don't know what they mean. If you see, they repeat from 50 Hertz to 50 Hertz. These little spikes. I'm making a connection because I'm in Europe and our frequency at the power outlet is 50 Hertz, and there may be some noise from the power outlet. I don't know, but again, it's too small to make a difference, so it doesn't interfere with the Thiele Small Parameter measurement. So we are done with the calibration. Now we can go ahead and hook up the speaker. So go ahead and click measure and then click start. That is our first measurement. And now we have to add the mass. Make sure that stuff sticks. And do another measurement. Now go to Tools, Thiele Small Parameters. This is the first measurement. This is the second with the added mass. 10.85 grams, 3.1 ohms, and 126.67 centimeters squared. Calculate parameters. And there you have it, your list of Thiele Small Parameters. Now let's compare the results. We have the DATs, the onboard sound card by itself, and the sound card amplifier combo. If you are curious to compare the DATs with the spec sheet of the speaker, I can already tell you that there are significant differences. This may be because I didn't burn in the speaker as long as I should. I did run it for 30 minutes before doing these measurements. Also, there are variations between production batches, so it's nothing to worry about. That's why you measure your speaker in the first place, so you don't use the numbers in the spec sheet. Now let's compare the differences between the measurement devices. If I consider the DATs to be the benchmark, then the combo with the amplifier seems more accurate. It's basically identical except for the QTS. The one without amp looks slightly worse, but again seems within the margin of error. Seems weird to me that VAS is almost identical, but QTS is not. QTS is an electrical parameter and should be easy to measure and be consistent between measurements, unlike VAS. Anyway, welcome to the world of audio, where you measure a speaker and everything is important. Do you have a quiet environment? Did you make sure that the speaker is firmly secured? Is your speaker broken in? Even variations in temperature can alter the results. I'm telling you all of this not to discourage you, on the contrary, I'm telling you this so you don't think you did something wrong if you don't get the results you hoped for. In conclusion, the jig with the amplifier is a better choice, but that doesn't mean that the simple jig using just the headphone output doesn't yield valid results. So don't rule out the simple jig if you want an easy measurement setup to build. In the end, I hope that my instructions were clear and people can make their own measurement setup. I'm going to link in the description all the instructions that you need to build these jigs and the parts you need. I wish you good luck and have fun measuring your speakers. Peace!